All right, today we're going to be talking about the constant of proportionality and whether relationships are proportional or not. So let's start with the definition of the constant of proportionality. When two quantities are in a directly proportional relationship, then the ratio of y to x is the constant of proportionality. We call it K. You can also call it slope, which you'll learn about more in 8th grade. Let's see. To find the constant of proportionality, we can divide y by x. And remember that a fraction is just a division problem, so we'll sometimes represent it like a fraction, as you see there. All right, so this will make more sense as we move through the notes, but there are 3 ways that we can show relationships and determine if they are proportional or non-proportional. We can do that through graphs, tables, and equations. We're actually going to break this up into 3 different lessons, but I'm going to do one video for all 3 topics and just post this same video for the 3 different days that we learn about it. All right, so first of all, the constant of proportionality, which we just said is represented by the letter K, can only be found if you have a proportional relationship. So first we have to determine if the relationship is proportional, and then we can find the constant of proportionality. So the first way, which I think is the easiest way, is if you're given a graph, or if you could make a graph. There are 2 things that a graph has to be in order for it to be proportional. It has to be a straight line, and it has to go through the origin, or the point 0, 0. So let's look at this example here on the left of this graph. We can see that it does go through the point 0, 0, the origin, and it's a straight line. So we can say that, yes, this is proportional. And then we can also find the constant of proportionality by dividing from any of the points. We can divide y by x. So you can just find a point on this graph where you're positive you know exactly the points it's going through, like maybe this one is over 2 and then up 3. So this point right here is the point 2, 3. We know 2 is the x and 3 is the y, so we're going to divide the y by the x, which is 2. And that would be our constant of proportionality, 3/2 or 1.5. It's also the slope. We learn more about slopes of lines next year, but the constant of proportionality in this case would be y over x, which is 3/2 or 1.5. This graph over here is not proportional. The reason it's not proportional is because it doesn't go through the origin. It's a straight line, but it has to be both. It has to be a straight line and go through 0, 0. So it does not go through 0, 0. So for a graph, you could just look at it and tell if it's proportional or not. If it's a straight line through 0, 0, it is proportional. If it's not straight or does not go through 0, 0, it's not proportional. The other way we can represent a relationship is through tables. You can see 2 tables here. They can either be vertical like the ones shown here or horizontal. If we, again, find that ratio of y to x for each pair of numbers in our table, if it's the same for all of them, then it's a proportional relationship. So let's try it. Let's divide the 2 by the 8, right? The y by the x, which is 1/4. Let's do it for the next set of numbers. Y divided by x is 1/4. Y divided by x is 1/4. Since they're all the same, we can say that yes, it's a proportional relationship. So you probably already know what's going to happen with this table over here because it's under the non-proportional column. Let's check it out though. Let's do the y divided by x. We get 1/4. And the y divided by x does not simplify to 1/4, and neither does this one. So if 2 of them are the same and 1 is not, it's still not proportional. Every single ratio of y to x needs to be the same. So we can say the ratios are not the same. or not equal. So it doesn't have a constant of proportionality because they're all different, all those ratios. Over here, in the first example with a table, the constant of proportionality is 1/4 because they're all the same. All right, last example is to represent the relationship through an equation. An equation is proportional if it can be written in this form, y equals kx, where k is the constant of proportionality. Here are two examples of proportional relationships in equations because we have y equals a number times x. This one, we don't have y by itself, but if we divided both sides by 3 and got y equals 3x, it would be in that form. What you want to look for to determine that it's not proportional is if they add something on over here. So let's look. In both of these cases, we have y equals 8x, but then they added this 10. So it's not in the form y equals kx. In this one, if I wanted the y all by itself, I could add 9 to both sides to get y equals 18x plus 9. But again, anytime you have this like extra number added onto it, then that's going to make it not go through the origin on the graph. And so it's going to not be proportional. So that's how you can tell if relationships are proportional or not. Oh, also, we did talk about how you could find the constant of proportionality from the graph and from the table. To find it from the equation, it's just this number in front of x. But you have to have it first in, oops, not that one. You have to have it in the form y equals kx first. So then it would be 3 for this one and 8 for this one. All right, that's it, guys. Thanks for watching.